I'm Allison Jonjak, the Cranberry Outreach Specialist with the University of Wisconsin-Madison Division of Extension. These videos are the on-demand recordings of UW Extension and the Wisconsin State Cranberry Growers Association's virtual brown bag lunch series. These monthly sessions offer growers and researchers a way to share timely and relevant information. We hope you'll enjoy and continue to engage with us.
Hi, I'm Tom Lochner, the Executive Director of the Wisconsin State Cranberry Growers Association. We're excited to be a partner with Extension to bring you research-backed resources, tools, and tips to keep Wisconsin marshes productive and profitable.
And so we will have just a little bit of housekeeping. We are recording this session. It can be available for those who were not able to attend today but want to keep up with the information that's being presented. There should be closed captions live already. If those are not showing up for you and you want them, click the little ... more. In general, we are watching the chat for questions. So if you have a question, I know I'm happy for you to unmute yourself and interrupt me and ask a question. You can also type in the chat. The little drop-down box can be to everyone or to Allison. So if you want to ask a anonymous question, use that little drop-down box to set it to Allison. Other than that, welcome to our fuel considerations Cranberry virtual brown bag for November 17th, the day before opening day. We are going to respond to some direct grower requests for how do we keep our fuel in the best quality when we're saving that across several years. Rick Grimm is with Inside FS, and he's the Central Area Energy Manager. He's going to give us about a half hour this morning, and I believe feel free to ask questions as we go. And then to wrap up the hour, I will give a recap of what we came up with as priorities from the research roundtable on Wednesday, just so that people who weren't able to attend that are able to catch up and keep abreast of our research priorities.
Okay. I'd like to start out by thanking everybody for this opportunity. And if there's questions that pop up that I can't maybe see or something in the chat, Allison, just jump on and let me know. I will take questions when I'm done too. And I will put up my information on my last slide in case anybody has any questions. My email, my phone number will be there, and anybody's welcome to contact me. I'm going to be talking about fuel storage and additives and why it's important, and where we've kind of come from the last 20 years and what's happened. So I'll start out with this slide here. We call it a gap exists between, and the orange here is the fuel. The blue is the engine. So if you go back to 1996, our fuel met the specs of our engines. We had no issues. We had no problems. Everything was good. As the EPA started requiring tighter restrictions on air pollution, so they put these standards in on the engines, and that's where you see this starting to climb here. After 96, they come out with the tier 1s, and of course the tier 2s, the tier 3s in 2006, and fuel did not change. Fuel stayed flat. Right here in 2006, maybe a little before that, but the government then regulated that we had to pull all the sulfur out of the fuel. So between here and here, our fuel dramatically changed just from pulling the sulfur out of it. And I will talk a little bit about that as we go through. And again, in 2011, you can see where there was a huge rise in more EPA regulations on the engines, which brought this gap further and further apart. So that's a little bit what I'm going to talk about to start out, and then I will go into fuel storage. So one thing I wanted to point out is all your EPMs, almost all of them, OEMs, I mean, almost all of them understand a reason for better fuel than our government standards. The government standards are still the same as they were back in 1996. So our fuel has not changed, and it's not going to change unless some standards change. But all the OEMs know it has to be changed, or you got to run some additives. There's just all this extra stuff now, and that's just well worth noting. I know most of you people out there probably run John Deere, Cats, any of these, Cummins, Volvo. They all are requiring that. So I'll jump in here, and I want to talk a little bit about this slide, because when I talked about right here in 2006, when they pulled the sulfur out of the fuel, we didn't see much change until it was about 4 or 5 years where we really started to see a change and see what was going on as an industry, with what changed in the fuel because pulling sulfur out. And that's why that line here declines down so far, is we seen that it changed the pH in the fuel, and it actually started to let microorganisms grow inside the diesel fuel. As an industry, we were shocked. How can this happen? What's going on? And it took us quite a few years to figure out exactly what is going on. So again, if you look, it widened that gap even more. And people started to really see some problems, and especially on the Cranberry marshes, where this fuel would sit in maybe on a lift pump, and you'd run it two maybe 3 times a year. That fuel sits there and old, and it gets stagnant. And if these microorganisms start growing in that fuel, they just continue to grow, and it kind of magnifies the problem on fuel sitting for a long time. So this is a fun fact on this slide. I think a lot of people don't know or don't realize. So ASTM D975 is a government standard for measuring and testing of fuels. One semi-load, 7,500 gallons is a semi-load. One semi-load of fuel can have up to 375 gallons of biofuel in it. And they don't have to say anything. They don't have to tell you. That's 5%. And that's kind of a problem for us up here in a cold climate. Biofuel don't work very well when it's 20 below. So that brings a lot of challenges to the industry. It can also hold up to 1 gallon of glycerin. And it's kind of important. Most people, what's glycerin do? Glycerin actually comes from the bio part of the fuel, and it reacts with additives, maybe some premium additives that are in that fuel. It can react with them, but it can also, too much glycerin in the fuel can destroy the inside of filters. So that's kind of important to know. It can also have up to 3 gallons of water in it. So every transport load can have up to 3 gallons of water in it. And right there, we have a water problem right off the bat that we didn't want, and then 1 cup of dirt. So I thought them were kind of fun facts that people don't know. So this is geared more towards the fuel quality and fuel quality management. And this is it's worth talking about the setup of these tanks. And one thing to raise the pitch, you can see, and you want your tank tilted backwards from your draw. So whether it's a duplex bushing on top with your engine sucking right out of the tank, or a pump like this one, you want them off the bottom, and you want the tank tilted back. White tanks are important, and shaded tanks. So if you can have roofs over them, the better. The more you can keep the sun off of that tank from them extreme temperature changes is very huge. One really important thing, especially for Cranberry marshes, is the venting. If we, the proper way probably to vent on a lot of these are pressure vents. Pressure vents are very expensive, but with a pressure vent, this tank will only vent when it absolutely needs to. And being it's diesel fuel, if it's a white tank and shaded, it won't vent very much. So when that tank vents, it has the opportunity to suck in moisture. Any evaporation that's around that tank, it can suck in. So that's one importance, especially we find on the Cranberry marshes. Another important thing is filter. Filtration is huge. If you can filter your fuel at the barrel before it goes to your engine, whether that be coming up, like I says, right out of direct draw out of a barrel, have a filter there before it goes to your engines, or you're pumping it into a machine. That's your first defense on anything. So it's important. And I want to point out on this slide a little bit here too, the water bottom in here, and I will talk about that a little bit, and the bacteria growth line here that we've been finding because they took the sulfur out of the fuel. This bacteria needs water to grow. It ain't just taking the sulfur out of the fuel that let it grow. It also needs water to grow too. And then here on the bottom, the sludge. Sludge could come from, like I said, that 1 cup of dirt and a transport load, but it could also come from dust maybe around the tank. And again, on the venting, it could come through the vent real easy, and you'll end up with some sludge on the bottom of the tank over time. My next slide shows a little bit what happens with fuel when water is introduced to it. I mean, we start out here with clean fuel, no water. And here, these slides kind of show maybe a little bit of evaporation coming in, and fuel can hold so much water. It can hold, I don't know the exact number, but it's a certain percentage of water, a very small percent, but it can hold and suspend it. And when it's in suspension like this, it'll burn, it'll go. It's so minute that it will pass through your machine. This one here is starting to get saturated. And it's starting to become to where it can only hold so much water. And if you come over to this slide, it's now beyond saturation point. And what happens is the water starts falling out of the fuel and it goes to the bottom. The fuel floats on top of the water, and that's where we get our water bottoms. So, I mean, it's just a fun fact seeing that, how this process kind of happens. I want to go back to this slide again. We were here last time we talked on what we've seen the differences from taking where the fuel change here, where it come down, and some of the algae growth that we were seeing, and some of the problems we were finding, and also along with this come more sludge, more dirt in the bottom of the tanks, and we were wondering why. So by getting on a good fuel quality management plan, you can start closing this gap up here. And part of that is identification. It's important to identify what we have going on now in our tanks. Do we have sludge on the bottom? Do we have a water bottom going on now? Do we have microorganisms starting to grow? And so basically the first start of that is identification. We go out and we will take bottom samples, we'll take core samples off of tanks, and we have ways of testing for microorganisms in the fuel. We can check for water, and basically that's the first step on a good fuel quality management program. The second step is additives, and I wanted to really touch base on this because of the way the engines change, and I know a lot of the Cranberry marshes now have a lot of newer engines out, whether it's an irrigation motor, lift pump. And it's important that we are running some kind of a premium fuel through them engines with the fuel that we have today. There's all different kinds of premium packages out there, and by law, a company can only have one of these in their package and call it premium. And of course, it's not a very good premium if they only have one of these in there. And understand that every one of these costs money per gallon. So some packages are better, some packages aren't. And I'll talk a little bit about these solvents down here really don't do a lot. They're more or less a filler. There's not a lot of purpose in solvents in an additive package. But I'll go through and I'll talk a little bit about each of these categories and what it kind of means. So a corrosion inhibitor, these are really, really important to have. Now these two pins here were submerged in a mixture of fuel and distilled water for 4 hours. I do not know the water ratio per fuel ratio. That part I don't know. It was at 100 degrees. The fuel was cooked to 100 degrees, which is relatively cool compared to when that fuel's in your engine. You can see this one here is all rust, and this one is not. Just by having a corrosion inhibitor in there, you don't have this rust. Without it, you have it. This exact same process is going on inside of your fuel tanks. That rust, without a corrosion inhibitor, you are building rust on the inside of that fuel tank. And eventually that rust is going to keep building, and it'll start scaling off, falling to the bottom of that tank. And you will pick up debris eventually. The next one is lubricity, and lubricity is probably, in my opinion, one of the most important things. And sulfur had all kinds of lubricity. So when we had the sulfur, we had lubricity. When they pulled that out, we lost virtually all of our lubricity. And then the combination of the engines changing with the injector nozzles getting tighter tolerances, and the injector itself being under way more pressure than the older engines were. So the injector tip now needs that lubricity now more than ever. So without an additive package running some kind of a lubricity, we could definitely see the industry has seen injector blowouts because of this. John Deere's a really big one. You blow an injector out on a John Deere tractor or engine or any kind of John Deere piece of equipment, and it's still under warranty. The first thing John Deere does is they take a fuel sample. And if you're not running some kind of additive package up to their specs, they will void that warranty. We've seen it happen. And it's just something everybody should be aware of. My next slide here is detergents. And this is not, I was trying to find a better slide, and this ain't really a good slide. I'll talk a little bit through it though. Without detergents, some of these tests, you will lose horsepower after so many hours. And really what's happening is a combination of a whole bunch of things. Part of it is you're getting, you're sucking dirt, debris. It could be dust, just fine particles, or plugging up filters. It also is plugging up the inside of your engine. When this dirt, debris, and small particles get inside the engine with the high heat that these engines are running and the high pressures, it actually starts cooking on and caking to all different parts of the engine. So it's one reason that is important. This slide over here was a test that was done on an engine. They started out with fuel with no detergent in it, and then they put detergent in it, and they found that after so many run hours up, the power on the engine actually started to increase again. These are really small, minute amounts, but it goes to show that it does work. This is a little bit what detergents actually do inside your fuel. So, and of course, these are just lab tests, and it's hard to duplicate anything in a lab that compares to happens out in the real world. But without detergents, what happens is your fuel gets so heavy with dirty materials, dust, dirt, whatever, and it'll fall to the bottom. And when it falls to the bottom, if you remember back on that one screen and you start building up and it gets into your draw pipe, you will start drawing them contaminants right off the bottom, and you will shut an engine down. It don't take very long. What the detergents do is they keep a lot of that dirt and debris suspended. If you have it in there, like I said, with good fuel quality maintenance and the right venting, you can minimize what you get in there. But the detergents trap all that up inside the fuel in such small, minute particles, it'll pass. You will catch a lot of this in your pre-filter, which that's the idea of it. You want to catch the stuff in your pre-filter. So, and over time, a really good detergent package will clean up a tank. It just takes time to do it. You will plug some filters if you have not been running a really good detergent package. So I just wanted to kind of touch base on that a little bit. Cetane, excuse me, I get a lot of questions on cetane. Cetane is another very, very important additive to put in. The government regulations state that the fuel coming out to us has to have a minimum of a 40 cetane in. 40 cetane is probably not enough. It should be anywhere from 45 to 47 to be for what our OEMs kind of require on a lot of these newer engines. And what cetane does, two things really primarily. Over here on this slide over here, the burn rate gets a lot longer when you have a higher cetane level in it. I believe this one is a 40 and this is a 45 cetane. So by getting a longer burn cycle, when this piston comes up to the top and your injector fires, it starts firing earlier. You get a longer burn, you burn all the fuel that's in there. You get more power and you're not leaving any fuel behind. And that's one big importance of it. The other big importance of it is you start igniting that fuel a lot sooner than you do with a lower cetane. So you get rid of maybe spark knock or maybe some other issues that occur with the engine just by starting that ignition point a lot earlier. So cetane is a very important thing to think about that, like I said, in the past, we didn't have to. So overall, going through here, like I said, started out 96, our fuels and our engines were the same. We went for a while. We didn't see a lot of problems in here. There wasn't a real big gap. And then when they started putting more pollution regulations on us and bringing us down to these levels, and then taking the sulfur out through here, and then seeing what happened to the fuel while they took the sulfur out here. We had a huge gap. With fuel quality maintenance and additives, we've closed that gap. We've now gotten back up to here where we were here. It's something. It's very important. I think this is going to continue to change as we go through the future. I think at some point in time, I'm hoping the government maybe put some higher standards on regulations on the fuel that we are getting out of our terminals. Another thing I wanted to kind of talk about a little bit, and I don't have a slide on this, is our crude quality that we've experienced probably since, even probably more around 2000. When we started pulling, especially in the Midwest, we started pulling a lot of shale crude out of mostly out of the Dakotas. A lot of shale crude was coming into this part of the country. Shale crude is not as good of a quality of crude, and it's harder to refine down to get to the government standards. That is one trick that the refineries use by putting, when I talked about the 5% bio, they can put 5% bio in there and raise the cetane of that fuel just enough, and it'll save them a lot of money on refining costs. So that's the reason they do that. So I just wanted to point that out too, with the changing of the crude to come some of these changes. So that's really kind of all I had. And I know I'm maybe a little bit short, but if anybody does have any questions, I'll be willing to answer them. Otherwise, like I said, my information is here on the bottom. Feel free to call me or email me. And I'll be happy to answer anybody's questions or come out and do some tank testing, whatever you guys think you may want.
Awesome. I definitely learned a lot just in our quick 20 minutes there. That was a lot of really useful information that I'm not super familiar with. Do you have, I guess, kind of quick hits if growers don't already have their tank set up, on a slope, and if they don't already have a filter from between tank and equipment, and if they don't already have shading, those are the top 3 things you would recommend? Is there? Give me a punch list for if I'm totally new to fuel.
Yeah.
What do I do?
The very first thing is, and especially we find it a lot on more so lift pump tanks is where we find it the most prevalent, I guess, is most of the time is the first step is to come in and identify what do we have going on, if we have anything going on. Identification is huge because we can correct them certain things on a tank, but if there's problems already existing in that tank, we're not going to get rid of them. So identifying what's in them tanks is really important. Once we identify what's in them tanks, it comes into cleaning them tanks up. There's different processes we have to do that. I mean, if the tanks are really, really bad, we do have a tank cleaning system. It's used a lot, so it's hard to get on the list to get doing. We are in the process of building another one, and it will come in and we will actually clean the crud and everything off of them tanks and filter all that fuel inside that tank a number of times through a 5-micron filter. Once we got that tank cleaned up, or any water sucked off the bottom, if it had a water bottom, then it comes to the point where, okay, now we need to set that tank up right. We need to get that tank pitched right, get the lines so they're maybe 4 or 5 inches off the bottom, maybe 6 inches off the bottom, and getting all that stuff correct. If we had microbial growth, or we identified we had microbial growth growing in that tank, if it goes untreated, it'll just keep growing. You're never going to kill it. There are chemicals out there that we can kill it. It takes time. And when you're going through that process, you will plug filters. When we kill that stuff, it actually dies and it goes down and settles to the bottom, and you will suck some of it up. And it could be a lengthy process to clean that tank up. But them are some of the most important things. I think the first thing is identifying it. And I've been through this scenario a lot. And maybe some growers out there too have, on irrigation tank at frost watch season, middle of the night, and all of a sudden your engine quits and you're like, what? And that's the exact time you don't want to see that problem. So it's critical to get them tanks checked, get a filter on them. It's a lot easier to change a filter, cheaper too, when it comes out of the barrel than it is to change the filters on them engines. There's different kinds of filters out there. Some of them that we install they have a clear outside shell, so you can actually physically see what's going on inside that filter. You can see if it's starting to get dark or starting to plug. Them are kind of nice. So it's just a combination of all kinds of things. But really, I think the most important thing is identifying what do you have. I mean, maybe we're good, maybe we're not, and just trying to find out so we can get them questions answered.
And that's a process that you have equipment for, or you are familiar with, and you can. That's
yes.
What is the check out the scenario process
so
look like?
I'll walk you through a normal what I do is, so I'll come out and we got a tool. It's a very simple tool actually. It's called an AccuGauge. We go then and that can take a bottom sample off your tank. Sometimes when the roofs are on the tanks, we can't get it in there, so it's a little difficult, but we'll work around it. But we go in and get a bottom sample, and that way, by getting a bottom sample, we can identify two things. Do we have sludge, crud, and or water on the bottom? Once we identify that and we know what we have on the bottom, we'll take a core sample. Sometimes core samples, mold and bacteria will be floating in the fuel, and you can visibly see it with your eye when you pull that sample out. When we can visibly see it, we know we have a major problem. If we're a little bit unsure, what we'll do is we will test it. It's a 72-hour test, but we can test for it, and it'll tell us to a certain degree if we have a start of a problem, maybe a mediocre problem or a really bad problem. So once we do walk through that process, and identifying what we have, a lot of it, I guess, really is initially visibly identifying what we have going on in that tank, and that is really easy to do. Like I says, come out and get a bottom sample off of them tanks. So.
Mm-hmm. I had a question come in on the chat. Any recommendations for the additive kind or brand? I have to put my little, I'm an extension with University of Wisconsin, so I am not endorsing any particular product. However, since Rick is here, Rick might give us a couple of his favorites.
Yeah, I'm not out there. I don't want to knock anybody's products or what they're doing. I don't pay attention to a lot of them. I know there's some very good products out on the market. I like to think our product, our D-Slux Gold Fuel, has that product in, is just as good or if not better than a lot of them out on the market. There are some fuel companies out there that are paying attention to this, and there's some that are not. So, I mean, I guess really it's talking to your fuel supplier. What do you have? What are you getting? What's in your premium package are questions to start with. And I, if they can tell you, based on, going off of that, comparing maybe to another vendor or just products off the shelf. You can buy products on the shelf. A lot of times they don't like to give their recipes up, but they will talk about on the bottles a little bit what's in them. So I guess talking through that with your fuel supplier, or like I said, if anybody's got any questions, I'm more than happy to talk through them and answer or try to answer anything that they would have. So.
And when you are, if I kind of go back to the slide of your optional mixes that might be the various premiums that various suppliers might have, are they probably a little bit, not going to give you the exact percentages, but will at least give you an option among these sorts of
Yes, so I can tell you this. These are actually real test results from different products. I can't name the products because we're not allowed to do that. And so you can tell by us coming in and testing competitors' products or other companies' products what the differences are. And everybody's got a little bit of a different recipe on what's going on. And they may have their different reasons for why, one's got more detergent, one's got less. This guy's got more corrosion inhibitor than this company, so there's different reasons. But, I can tell you this one, and this one are a better quality package than this one is. You're getting more bang for your buck. Like I said, I started off saying solvents really don't do a lot. There's not a lot of purpose in solvents, but I feel cetane, lubricity, and detergents. I guess all these are just as important as each, but again, it's talking through what you are using now, and maybe looking at other products that you could be using. Are they better? Are they not? And that's really the questions to ask.
Fantastic. If you want to go back to your last slide that's got your contact information, it was, I believe, Chris Parker that had made this connection for us when we heard growers saying we wanted to learn about fuel. Chris connected us to Rick, so we're glad for the insight from an expert, and hopefully that'll help everyone avoid those middle of the night startles of your engine suddenly giving out on you.